What if I told you that the Andromeda Galaxy, our closest galactic neighbor, holds secrets so strange they defy everything we thought we knew about the cosmos? Picture a vast, swirling halo of ancient stars, dark matter, and something even more mysterious, bizarre objects drifting silently through the darkness, waiting to be discovered. This isn't science fiction, it's real, and it's happening right now in the depths of space. Galactic halos are like the ghostly fingerprints of a galaxy's past, stretching far beyond the bright spiral arms we see in telescopes. They're filled with the remnants of cosmic collisions, wandering stars, and invisible dark matter. But Andromeda's halo is different. It's larger, weirder, and packed with anomalies that have left astronomers scratching their heads. Some of these objects move in ways that shouldn't be possible. Others emit signals that don't match any known celestial bodies. And then there are those that simply vanish without a trace, as if the galaxy itself is playing hide and seek with us. Why does this matter? Because every strange object we find in Andromeda's halo is a clue, a piece of a puzzle that could rewrite our understanding of how galaxies form and evolve. It's like stumbling upon a hidden chapter in the universe's history book, one that might reveal how Andromeda grew so massive, how it's destined to collide with our own Milky Way, and what secrets lie in the shadows between stars. This is more than just astronomy, it's a cosmic detective story, and you're invited to join the investigation. So let's dive into the unknown and uncover 30 of the most enigmatic objects lurking in Andromeda's halo, each one stranger than the last. The first of these cosmic oddities is something straight out of a galactic crime scene, a colossal river of stars called the Giant Stellar Stream, stretching nearly 200,000 light-years across Andromeda's halo. Imagine a glittering serpent of orphan stars, torn from a smaller galaxy that dared to venture too close to Andromeda's gravitational grasp. This isn't just a random cluster. It's a fossilized record of a brutal encounter from billions of years ago, when a dwarf galaxy was ripped apart and its stars scattered like cosmic breadcrumbs. What makes this structure so bizarre is its sheer scale and defiance of expectations. Most galactic mergers leave behind messy, chaotic debris, but this stream is eerily smooth and coherent, as if the universe took a paintbrush and drew a single, deliberate stroke across the darkness. Astronomers call it stellar archaeology. By studying the motion and chemistry of these stars, they've pieced together the story of the victim galaxy, revealing it was likely devoured by Andromeda around 9 billion years ago. The stream's stars move in unison, like a school of fish trapped in an invisible current, betraying the presence of dark matter shaping their path. This ghostly ribbon challenges what we know about galactic evolution. Most halos are cluttered with chaotic debris, yet Andromeda's halo contains this bizarrely orderly structure, hinting at a past far more violent and far more precise than we ever imagined. It's a reminder that galaxies aren't just static islands of stars. They're dynamic, ever-changing beasts growing by consuming their neighbors and this stream. It's the aftermath of Andromeda's last cosmic meal, still visible billions of years later. Next up is something far older and more enigmatic, a ghostly globular cluster drifting silently through Andromeda's halo like a relic from the dawn of time. Unlike the vibrant star clusters we're used to seeing, this one is dim, almost translucent, as if the light from its ancient stars is barely clinging to existence. What makes it truly strange isn't just its eerie appearance, but what it's made of, or rather, what it's missing. This cluster has shockingly low metallicity, meaning its stars contain almost none of the heavier elements forged in supernova. It's a cosmic time capsule, preserving the pristine chemistry of the early universe before generations of stars had a chance to pollute space with metals. Astronomers call objects like these fossils of the first galaxies, and for good reason. Most globular clusters we see today are dense, glittering balls of stars packed with metals, but this one is a ghostly outlier. Its stars were born in an era when the universe was still young and raw, composed almost entirely of hydrogen and helium. Spotting it in Andromeda's halo is like finding a cave painting hidden beneath layers of modern art, a rare, undisturbed glimpse into a forgotten chapter of cosmic history. But here's the puzzle. Clusters this ancient and metal poor shouldn't exist in a galaxy like Andromeda. They're supposed to be the building blocks of dwarf galaxies, not tucked away in the halo of a giant spiral. Some theories suggest it was stolen from a tiny galaxy Andromeda devoured long ago, while others propose it formed in place under conditions we don't yet understand. Either way, its very presence challenges our models of how galaxies grow and evolve. And then there's its eerie behavior. Unlike younger clusters which orbit predictably, this one moves with a strange, almost hesitant trajectory, as if it's being tugged by unseen forces. Some researchers suspect dark matter might be warping its path, while others wonder if it's a surviving fragment of a much larger structure that's since been torn apart. One thing's certain, this faint, ancient cluster is more than just a curiosity. It's a whisper from the universe's infancy, and decoding its secrets could rewrite what we know about the origins of galaxies. Deep in the halo of the Andromeda Galaxy, something invisible bends the fabric of space itself, a clump of dark matter so dense and isolated that it defies everything we thought we knew about how this mysterious substance behaves. Unlike typical dark matter, which blankets galaxies in diffuse halos, this anomaly lurks alone, untethered to any visible stars or gas, a cosmic phantom detected only by the way its gravity warps the light of distant galaxies behind it. Gravitational lensing reveals its presence like a shadow passing over a spotlight, distorting the images of background objects in ways that betray its immense mass. But here's the puzzle. Dark matter isn't supposed to clump this way without the gravitational anchor of regular matter. Current theories suggest dark matter should be smoothly distributed or clustered around galaxies, not floating freely in such a concentrated knot. Yet this one sits in defiant isolation, as if it's somehow avoiding the rules that govern the rest of the universe. What could explain such a strange formation? Some scientists propose it's the remnant of a long-dead dwarf galaxy, its stars and gas long since stripped away by Andromeda's gravity, leaving only the dark matter skeleton behind. Others speculate it might be evidence of an exotic form of dark matter, one that interacts with itself in ways we haven't yet imagined, clumping together like cosmic glue. There's even a wilder possibility. What if this isn't just dark matter at all? Could it be hiding something even more elusive, like primordial black holes or a crack in our understanding of gravity itself? The implications are staggering. If this clump is a sign of self-interacting dark matter, it could rewrite decades of astrophysics, forcing us to reconsider the very nature of this invisible scaffolding that holds galaxies together. Or perhaps it's a cosmic fossil, a relic from Andromeda's violent past when it cannibalized smaller galaxies and left their dark matter behind like ghostly trophies. Whatever the truth, one thing is certain. This dark, silent intruder in Andromeda's halo is a reminder of how much we still don't know about the universe's deepest secrets. There's a monster on the loose in Andromeda's halo, a supermassive black hole, hurled from the galaxy's core at speed so staggering it could cross the distance between Earth and the Moon in just 14 minutes. This isn't some quiet exile, it's a cosmic catapult launched by one of the most violent events in the universe, a collision between two black holes so powerful it warped the fabric of spacetime itself. Most supermassive black holes sit like anchors at the hearts of galaxies, but this one is different. It's a renegade racing through the halo at thousands of kilometers per second, leaving a trail of chaos in its wake. Imagine the force required to eject something millions of times heavier than our Sun. It's like kicking a cannonball so hard it escapes Earth's gravity. The culprit, a galactic merger billions of years ago, when a smaller galaxy plunged into Andromeda, their central black holes spiraling toward each other in a deadly dance. When they finally collided, the resulting gravitational waves were so uneven, they acted like a cosmic slingshot, flinging one of the black holes into the void. But the real mystery lies in what it left behind. Unlike a quiet exit, this black hole didn't leave alone. As it was ejected, its gravity ripped through clouds of gas and stars, dragging some along like a wrecking ball through cosmic scaffolding. Telescopes have spotted a bizarre, twisted trail of young stars in its wake, stars that shouldn't exist so far from the galaxy's center. Normally, star formation requires dense, cold gas, but this black hole's violent passage heated and compressed the material it encountered, sparking improbable bursts of stellar birth. It's as if a tornado tore through a desert and in its wake flowers sprouted from the sand. The implications are staggering. If a black hole this massive can be ejected, what does that mean for other galaxies? Could the Milky Way someday suffer the same fate when it collides with Andromeda? And what happens to a galaxy when its central anchor is suddenly gone? Some theories suggest the remaining black hole in Andromeda's core now orbits off-center, causing subtle ripples in the motion of nearby stars. Others speculate that the runaway might eventually slow down, lurking in the halo as a silent predator, waiting to devour any unsuspecting gas or stars that drift too close. One thing's certain, this rogue black hole is more than just a curiosity. It's a testament to the raw, chaotic power of galaxy mergers and a preview of the explosive future awaiting our own corner of the cosmos. Tucked away in the outer reaches of Andromeda's halo, there's a cosmic relic so pristine, it feels like stumbling upon a fossilized bubble from the universe's earliest days, a dwarf galaxy with almost no heavy elements in its stars. This isn't just another small galaxy, it's a living time capsule, preserving conditions from an era before supernova had scattered metals across the cosmos. Most galaxies, even tiny ones, show signs of enrichment from generations of star death, but this one is different. Its stars burn with the purity of hydrogen and helium alone, as if the universe hit pause 13 billion years ago and forgot to press play again. The mystery isn't just its composition, it's how it survived at all. Galaxies like this were thought to be the building blocks of giants like Andromeda, consumed long ago in the chaos of cosmic collisions. Yet here it floats untouched like a lone survivor of a forgotten war. Its very existence forces us to reconsider how galaxies like Andromeda grew. Did it form in isolation, somehow avoiding the gravitational pull of larger structures? Or was it protected by an invisible cocoon of dark matter, shielding it from the forces that shredded its siblings? What's even stranger is its motion. Unlike other dwarf galaxies orbiting Andromeda in predictable paths, this one drifts lazily, as if it's barely tethered to the halo. Some astronomers suggest it might not even be a true satellite. It could be a rare flyby galaxy, just passing through after billions of years wandering the void between giants. If true, it would make this metal-poor dwarf even more extraordinary, a cosmic hitchhiker that wandered into Andromeda's grasp by chance rather than destiny. But the real puzzle lies in its stars. Most primordial galaxies were thought to form stars in frenzied bursts, but this one's stellar population is oddly tranquil, with no signs of the violent bursts of star formation we'd expect. It's as if it quietly forged its stars in isolation, undisturbed by the chaos unfolding around it. Could this be a glimpse of what the universe's first galaxies truly looked like? Quiet, inefficient star factories, nothing like the violent nurseries we've come to associate with the early cosmos. Every observation raises new questions. If galaxies like this were common in the early universe, why is this one of the few survivors? And what does its presence tell us about the conditions that allowed such fragile structures to endure against all odds? Each answer we find peels back another layer of mystery, reminding us that the universe still holds ancient secrets in plain sight, if only we know where to look. Hidden in the depths of Andromeda's halo, An enormous, shapeless blob pulses with radio waves so intense they dwarf entire galaxies, a cosmic anomaly with no clear explanation. This isn't just a cloud of gas or a cluster of stars. It's a sprawling, invisible beast detectable only by the eerie glow of its radio emissions, stretching across thousands of light years like a phantom whispering in wavelengths our eyes can't see. The strangest part, there's nothing visible at its center, no black hole, no galaxy, no obvious engine powering its outbursts. It's as if the radio waves are conjured from empty space itself, defying every known source of such energetic emissions. Some astronomers believe this could be the corpse of a quasar, a once gigantic black hole that feasted on surrounding matter billions of years ago, blasting out jets of energy before vanishing into obscurity. But here's the twist: the blob's radio signature doesn't match any known quasar remnant. The energy patterns are smoother, more diffuse, as if something stretched and smeared the dying quasar's final scream across eternity. Others argue it might be something far stranger, a cosmic collision frozen in time. Picture two galaxies clashing in the distant past, their supermassive black holes spiraling toward each other and unleashing titanic shockwaves that heated the surrounding gas to millions of degrees. The resulting energy could have created a vast, invisible bubble of radio noise, lingering long after the galaxies merged into Andromeda. But simulations struggle to reproduce the blob's exact structure, leaving scientists to question whether they're missing a piece of physics entirely. Then there's the wildcard theory. What if this is evidence of an entirely new astrophysical phenomenon? The blob's radio waves pulse with odd, irregular rhythms, unlike the steady hum of black holes or the predictable decay of supernova remnants. Some researchers whisper about dark plasma, a hypothetical form of matter interacting weakly with light but strongly with radio waves. Or perhaps it's a vast, ancient magnetic field, frozen into space like a relic from the universe's infancy, slowly unraveling and releasing energy in cryptic bursts. Whatever the truth, this ghostly radio blob is more than a cosmic oddity. It's a challenge to our understanding of how energy moves through the universe. Every telescope pointed at it raises new questions, and with each answer we scrape together, the mystery only deepens. One thing's certain: in the silent expanse of Andromeda's halo, something invisible is screaming. We just don't know why. Streaking through the darkness of Andromeda's halo like a cosmic bullet, one star defies all expectations. A hypervelocity rebel traveling fast enough to cross the entire Milky Way in just 20 million years. Most stars orbit galaxies in predictable loops, bound by gravity's relentless pull. But this one moves with such reckless speed it's practically escaping the galaxy altogether. Clocking in at over 1,000 kilometers per second, it's not just fast, it's a gravitational anomaly, a runaway whose trajectory paints a secret map of Andromeda's hidden forces. How does a star reach such impossible speeds? The answer lies in violence. One theory suggests it was once part of a binary system, orbiting a massive partner that went supernova. When that star exploded, the sudden loss of mass released its companion like a slingshot, catapulting it into the void. But the more tantalizing possibility involves Andromeda's central black hole. Imagine this star wandering too close to the monster at the galaxy's heart, where the black hole's gravitational pull captured its partner and flung this survivor outward with enough energy to nearly escape the galaxy entirely. It's the cosmic equivalent of a car spinning out on a curve. Only here, the curve is space-time itself. What makes this star truly invaluable isn't just its speed, but the clues it leaves behind. Like breadcrumbs in a forest, its path traces the invisible contours of Andromeda's gravitational field. Dark matter, black holes, even the distribution of gas, each tugs subtly at the star's trajectory, leaving a fingerprint astronomers can decode. By tracking its movement backward, scientists have reconstructed the gravitational hills and valleys of Andromeda's halo, revealing pockets of hidden mass that telescopes can't see. Yet the star isn't just a tool, it's a puzzle unto itself. Spectroscopic analysis shows it's surprisingly rich in heavy elements, suggesting it wasn't born in the halo's primordial outskirts but in the galaxy's crowded core, where generations of supernova enriched its composition. This raises a haunting question. How many other stars have been hurled into the darkness by Andromeda's gravitational forces, and what stories might they carry from the galaxy's violent heart? As it barrels through the halo, this hypervelocity fugitive serves as a reminder. Even in the vast quiet of intergalactic space, nothing is ever truly at rest. The universe is a place of chaos and momentum, where stars become both messengers and projectiles, and sometimes the key to unlocking a galaxy's deepest secrets. Drifting silently through Andromeda's halo, an enormous shroud of hydrogen gas stretches wider than the Milky Way itself, yet it's so cold and faint that no telescope can see it directly. This isn't just any gas cloud, it's a cosmic ghost detectable only by the faint whispers of radio waves it emits, revealing the presence of enough raw material to build millions of stars. But here's what baffles astronomers. Despite its staggering mass, this cloud has remained eerily sterile, a nursery where no stars have ever been born. The mystery lies in its temperature. Most star-forming clouds are dynamic, turbulent places where pockets of gas collapse under their own gravity, igniting the fusion furnaces of new stars. But this cloud is different. It's colder than the space around it, hovering just a few degrees above absolute zero. Without the usual churn of heat and motion, the gas remains stubbornly still, like a frozen lake refusing to ripple even in the fiercest storm. Some researchers believe it might be a relic from Andromeda's violent youth, a leftover scrap of primordial gas that never got stirred into the galactic mix. But the plot thickens. This cloud isn't floating aimlessly. It's moving with purpose, tracing an orbit that suggests it's bound to Andromeda's halo, not just passing through. That raises a tantalizing question. How has it survived intact for so long? Galactic halos are brutal environments where radiation and gravitational tides shred fragile gas clouds over time. Yet this one persists as if shielded by some invisible barrier. One theory points to dark matter, proposing that an unseen clump of it might be cocooning the gas, protecting it from the forces that should have torn it apart eons ago. Even stranger is what the cloud doesn't contain. Unlike typical interstellar gas, which is laced with traces of heavier elements from dead stars, this cloud's composition is almost purely hydrogen and helium, a chemical fingerprint suggesting it's never been near a star-forming region. It's like finding a pristine ice core from Earth's ancient atmosphere, untouched by the pollutants of modern life. That purity makes it a rare window into the raw ingredients of the early universe before generations of supernova enriched cosmic gas with metals. The most haunting possibility, this cloud might not be alone. If it's truly a surviving fragment of the gas that built Andromeda, there could be others like it lurking in the halo, invisible archives of the galaxy's construction process. Each one would be a time capsule, holding secrets about how spiral galaxies like ours assemble their colossal structures from the chaos of the cosmos. For now, this ghostly cloud remains a paradox, an ocean of potential that refuses to create, a shadow from the past that still has stories to tell. At the heart of Andromeda's halo, two colossal star clusters whirl around each other in a gravitational waltz so tight it defies the laws of cosmic motion, a pair of stellar titans that might be the last surviving core of a galaxy Andromeda devoured long ago. These aren't just any clusters, they're denser, brighter, and far more massive than typical globular clusters, packing enough stars to rival small galaxies. Yet here they are, locked in an orbit so close they could fit within the distance between our Sun and its nearest stellar neighbor, Proxima Centauri. The sheer physics of their dance is staggering. Objects this massive should have either merged or flung each other apart by now, yet they spin on, untouched by time or disruption. What makes this duo truly extraordinary is their composition. Most globular clusters are ancient relics, but these two burn with a mix of young, blue stars and old, red giants, as if they've been forging new stars long after their formation. That's unheard of for isolated clusters unless, of course, they weren't always isolated. The leading theory: these clusters are the fossilized nucleus of a dwarf galaxy that once orbited Andromeda, its outer stars stripped away by tidal forces until only its dense central heart remained. It's like finding a pair of diamonds in the rubble of a demolished building, the last indestructible remnants of a structure that no longer exists. But their defiance of expectations doesn't stop there. The clusters move with near-perfect symmetry, their orbits so precise they almost seem choreographed. Normally, gravitational interactions between such massive objects would destabilize their paths over time, yet these two have maintained their intimate dance for billions of years. Some astronomers suspect dark matter might be the unseen anchor, a hidden halo left over from their parent galaxy, subtly steadying their motions. Others propose something even wilder, that the clusters themselves might harbor intermediate mass black holes at their centers, their gravitational influence acting like cosmic counterweights to keep the system balanced. The implications ripple far beyond Andromeda. If these clusters truly are the stripped core of a cannibalized galaxy, they could rewrite our understanding of how large galaxies grow. Most models assume smaller galaxies are torn apart completely, leaving no trace. But here's proof that some galactic nuclei can survive even the most violent mergers, orbiting their captor like silent witnesses to the brutality of cosmic evolution. And if black holes are lurking within them, it would solve a long-standing mystery where the missing middleweight black holes of the universe have been hiding. One thing's certain: this double nucleus remnant isn't just a curiosity. It's a snapshot of galactic cannibalism frozen in time, a clue to how galaxies like Andromeda became so vast, and a reminder that even in the depths of space, some things refuse to go quietly. Lurking in the outer fringes of Andromeda's halo, a ghostly smear of starlight defies every expectation. An ultra-diffuse galaxy so faint, so delicate, it barely qualifies as a galaxy at all. Picture a cosmic phantom, stretching as wide as the Milky Way but containing less than 1% of its stars. A wispy veil of stellar light so sparse you could fly through it for light years without spotting a single sun. This isn't just a dim galaxy, it's a celestial paradox, a structure so fragile it should have been torn apart by Andromeda's gravity eons ago. Yet here it floats intact, as if the universe forgot to erase it. What makes this galaxy so baffling isn't just its scarcity of stars, it's the way they're arranged. Unlike the dense, bustling neighborhoods of typical galaxies, this one's stars are scattered like lonely lanterns in an endless field, with vast, empty gaps between them. Under normal circumstances, such a sparse structure would collapse inward or disperse into the void. Yet something, perhaps an unseen cocoon of dark matter, holds it together against all odds. The galaxy's transparency is so extreme that astronomers first mistook it for a flaw in their instruments, a smudge on the lens of reality itself. Then there's the mystery of its survival. Andromeda's halo is a gravitational gauntlet where tidal forces shred fragile objects over time. Most dwarf galaxies that venture too close are stretched into streams of stars, their identities erased. But this ultra-diffuse galaxy persists, orbiting undisturbed like a feather caught in a hurricane. Some theories suggest it's protected by its very emptiness. With so little mass, it barely interacts with Andromeda's pull, slipping through the gravitational cracks unseen. Others propose it's a newcomer, a wandering galaxy only recently captured, its final dissolution still millennia away. But the real enigma lies in its origins. Did it form this way, a failed galaxy born with too little gas to ignite prolific star formation? Or was it once more robust, its stars stripped away by some ancient collision, leaving only this wispy skeleton behind? The answer could rewrite what we know about galaxy formation, proving that the universe builds not just in fire and fury, but in whispers and shadows. Perhaps most haunting of all is what this ghostly galaxy implies about the cosmos. If structures this fragile can endure, how many others like it linger unseen in the halos of galaxies, waiting to be discovered? Each one would be a testament to the quiet, overlooked resilience of the universe, a reminder that even in the vastness of space, some things endure not by strength, but by vanishing just enough to escape notice. Buried in the depths of Andromeda's halo, a titanic sphere of scorching gas glows with the fury of 1,000,000 suns, an X-ray bubble so vast it could swallow our entire Milky Way whole. This isn't just a cosmic cavity, it's a fossilized explosion, a remnant of violence so extreme it sculpted the galaxy's history. The bubble's surface shimmers with X-rays, betraying the presence of gas heated to tens of millions of degrees, temperatures far hotter than the core of a star. Something here unleashed energy on a scale we can barely comprehend, and the echoes of that cataclysm still ripple through space today, the leading suspect. A quasar, a ravenous supermassive black hole that once feasted on surrounding matter with such ferocity. It belched out jets of energy powerful enough to blow a hole in the galaxy itself. Imagine a dragon sleeping at Andromeda's core, awakening just long enough to breathe fire across the cosmos before retreating into slumber. Those jets would have carved through clouds of gas like a cosmic blowtorch, leaving behind this cavern of superheated plasma. But there's another possibility, a starburst so intense it resembled a galactic supernova. Picture a chain reaction of star formation, where thousands of massive stars ignited in quick succession, their combined stellar winds and supernova punching a hole in the surrounding gas. Either scenario would explain the bubble's staggering energy, but which one really happened? Here's where the X-rays tell a story no visible light could. By analyzing their patterns, astronomers have reconstructed the bubble's explosive birth. The gas isn't just hot, it's laced with heavy elements like iron and silicon, the telltale ashes of countless supernovae. That points to a starburst, but there's a twist. The bubble's shape is too perfect, too spherical, unlike the messy debris normally left by star formation. Quasar jets, in contrast, tend to create smoother structures, their energy focused into precise cones. Unless, of course, the starburst was so coordinated, it mimicked a quasar's precision, a possibility that challenges everything we know about chaotic star formation. Then there's the timing. The bubble's gas is cooling far slower than expected, as if some invisible force is reheating it. Could Andromeda's central black hole still be whispering to this ancient wound, its faint radiation preventing the cavity from closing? Or is there another, darker explanation? Some theorists suggest the bubble might be filled with dark matter particles colliding and releasing energy, a hidden engine prolonging the aftermath of a catastrophe that should have faded eons ago. Whatever the truth, this X-ray bubble is more than a scar. It's a window into Andromeda's most violent eras. It proves that even the quietest-looking galaxies are built on foundations of chaos, and that the universe's most dramatic stories are often written in light we can't even see. Floating in the silent void between galaxies, a cluster of stars drifts like a ship without a harbor, untethered, unclaimed, and utterly alone. This isn't just another group of stars, it's a cosmic vagabond, a celestial anomaly that somehow escaped the gravitational pull of Andromeda and now roams the intergalactic darkness. Most star clusters are bound to their parent galaxies, orbiting in predictable paths, but this one defies the rules, moving with a freedom that challenges our understanding of how such structures form and survive. The mystery begins with its composition. Unlike typical globular clusters, which are dense balls of ancient stars, this group is looser, younger, and strangely rich in heavy elements. That's the first clue. It didn't form in the quiet outskirts of a galaxy, but was likely born in the chaotic heart of one. One theory suggests it was violently ejected, perhaps by the gravitational slingshot of a supermassive black hole or the shockwaves of a nearby supernova. Picture a stellar game of pinball where stars are flung into the abyss by forces beyond their control. But there's another, even more intriguing possibility. This cluster might not be a runaway at all. What if it formed in situ, right there in the empty space between galaxies? It sounds impossible, but recent simulations show that under rare conditions, vast clouds of gas drifting in the intergalactic medium could collapse and ignite stars without ever belonging to a galaxy. These orphan stars would be the cosmic equivalent of a child raised by wolves, untethered from the usual stellar nurseries, yet burning just as bright. Then there's the question of survival. Intergalactic space is a harsh environment, devoid of the dense gas and dust that typically shield young stars. Radiation from nearby galaxies and the relentless pull of dark matter should have torn this cluster apart long ago. Yet here it is, holding together against all odds. Some astronomers suspect it's cloaked in a hidden shroud of dark matter, its invisible gravity acting like an anchor in the void. Others wonder if it's just luck, a fleeting moment of stability in an otherwise unforgiving cosmos. Whatever its origins, this cluster is more than a curiosity. It's a test case for the extremes of stellar existence. If stars can form and endure in the emptiness between galaxies, what else might be lurking out there, unseen and uncharted? The universe has a habit of defying our expectations, and this lonely cluster is a reminder that even in the vast, ordered structure of the cosmos, there's always room for the unexpected. Deep within Andromeda's halo, a cosmic contradiction unfolds, a stellar nursery where stars are born in near total darkness, defying every textbook model of star formation. This isn't just another star-forming region. It's a shadowy realm where gravity works in silence, forging new suns without the glowing gas clouds or brilliant nebulae we typically associate with stellar birth. Most stars form in dense, luminous cocoons of gas and dust, lit by the energy of nearby young stars. But here, the process is eerily invisible, as if the universe forgot to turn on the lights. What makes this nursery so baffling is its apparent lack of the raw materials needed to create stars. Telescopes detect faint whispers of infrared light, evidence of newborn stars, but almost none of the telltale gas clouds that should surround them. It's like walking into a delivery room and finding babies, but no parents, no doctors, no signs of how they got there. The leading theory: this region might be dominated by something far stranger than ordinary gas, cold, dark matter. While dark matter can't collapse to form stars itself, its gravitational pull could be sculpting pockets of ordinary matter so efficiently that stars ignite in near total secrecy, hidden from traditional observations. But there's another possibility, one that challenges our understanding of interstellar chemistry. Could this be a graveyard of molecular gas so cold and dense it's virtually undetectable? Most star-forming gas emits faint radio waves as it cools, but simulations suggest that under extreme conditions, hydrogen molecules could clump together without radiating any energy at all, forming dark gas clouds that slip past our telescopes. If true, these invisible reservoirs might be far more common than we realize, lurking in the halos of galaxies like Andromeda, quietly feeding star birth in the shadows. The implications are profound. If stars can form in such darkness, it would mean our current census of star-forming regions is incomplete, like mapping a city by streetlights alone, missing every house hidden in the unlit alleys. Astronomers are now racing to uncover other dark nurseries, using subtle gravitational lensing effects or the faint heat signatures of their infant stars to trace these enigmatic structures. Each discovery peels back another layer of the mystery, revealing that even in the brightest galaxies, some of the most fundamental processes unfold where we least expect to find them, hidden in plain sight, waiting for us to look beyond the light. Amid the scattered wreckage of an ancient galactic collision, something extraordinary took shape, a tiny, defiant galaxy known as a tidal dwarf, stitched together from the torn-apart remains of its ancestors. Unlike most galaxies which form from the top-down collapse of massive gas clouds, this one was born from chaos, assembled piece by piece from the debris of a violent encounter between Andromeda and another galaxy billions of years ago. It's the cosmic equivalent of a phoenix rising from the ashes, only instead of fire, this rebirth was fueled by gravity's patient pull. What makes this tidal dwarf so fascinating isn't just its origin story, it's the way it flips the script on galactic evolution. Typical galaxies start with vast halos of dark matter that act like scaffolding, drawing in gas and dust to form stars. But this one is different. It contains almost no dark matter at all, a revelation that sent shockwaves through the astronomy community. Instead, it's held together purely by the gravity of its own stars and gas, like a sandcastle built without a mold. That absence of dark matter challenges one of cosmology's core beliefs, that galaxies can't form without this invisible glue. Yet here it is, a living counterexample drifting through Andromeda's halo. Then there's its chemical makeup, which reads like a cosmic contradiction. While most dwarf galaxies are metal-poor relics of the early universe, this one is oddly rich in heavy elements, far richer than it should be for its size and age. The explanation lies in its violent birth. When Andromeda ripped apart its parent galaxy, it scattered gas that had already been enriched by generations of supernova, like a chef tossing pre-seasoned ingredients into a new dish. This tidal dwarf formed from that recycled material, inheriting a chemical legacy it never earned on its own. But the real mystery is its resilience. Tidal dwarfs are fragile by nature, expected to dissolve back into the halo over time. Yet this one has endured, its stars clinging together against the tide of Andromeda's gravity. Some researchers speculate it might be cocooned in a pocket of unusually calm space, sheltered from the forces that should have shredded it. Others wonder if it's secretly anchored by something we can't see, not dark matter, but perhaps a dense knot of baryonic material lurking in its core. Whatever the case, this tiny galaxy is rewriting the rules. It proves that the universe can build galaxies in ways we never imagined, turning destruction into creation, chaos into order. And as we study its unusual chemistry and improbable structure, we're forced to ask, how many other cosmic rule breakers are hiding in plain sight, waiting to be discovered? Looming like a spectral mist across the vast expanse of Andromeda's halo, an eerie gamma-ray glow pulses with energies that shouldn't exist, a faint, omnipresent fog that defies straightforward explanation. Unlike the brilliant bursts of gamma rays from collapsing stars or colliding black holes, this emission is subtle, uniform, and suffused through the halo like cosmic static. At first glance, it could be dismissed as background noise, but the pattern is unmistakable. A whisper of radiation that clings to the halo's contours, hinting at processes far stranger than ordinary astrophysics. The leading hypothesis, dark matter's final act. Some theories suggest this glow could be the radioactive echo of dark matter particles decaying or annihilating after billions of years of silent existence. Picture an invisible sea of these particles finally meeting their end, releasing a flash of gamma rays as they vanish into nothingness. If true, it would be the first tangible evidence of dark matter's true nature, not just its gravitational influence, but its very particles transforming before our eyes. The energy signature matches predictions for certain exotic dark matter models, particularly those involving weakly interacting massive particles or WIMP. But here's the catch. No one can agree on whether the signal is strong enough to be definitive, or if it's just an illusion crafted by overlapping astrophysical phenomena. Then there's the cosmic ray alternative. For nearly a century, we've known that high-energy particles from supernova and other violent events can travel vast distances, colliding with interstellar gas to produce gamma rays. But the fog's distribution is all wrong. Instead of clustering around star-forming regions or supernova remnants, it blankets the halo evenly, as if painted there by an unseen hand. Some researchers argue these rays might be relics from Andromeda's youth, trapped in magnetic fields for eons, slowly leaking their energy like a battery left to drain. Others propose an even wilder idea, that the gamma rays are the fingerprints of primordial black holes, tiny, ancient singularities left over from the Big Bang, evaporating over time through Hawking radiation. The debate grows thornier when you consider the Milky Way's own gamma-ray halo, which bears a suspicious resemblance to Andromeda's. If both galaxies share this feature, does that point to a universal dark matter signal, or merely a shared astrophysical process we haven't yet deciphered? The answer could redefine our understanding of particle physics, dark matter, and the very fabric of galactic evolution. For now, the gamma-ray fog remains one of the most tantalizing enigmas in modern astronomy, a riddle written in light we can barely detect, waiting for the right key to unlock its secrets. Hanging adrift in the emptiness of Andromeda's halo, a luminous ring of gas pulses with colors no living star could produce, the ghostly remains of a dying sun's final breath. This planetary nebula should be anchored by a white dwarf, the dense, smoldering core of the star that created it. But when astronomers search the heart of this glowing shell, they find only darkness. The star has vanished without a trace, leaving behind its radiant funeral shroud as the sole evidence it ever existed. Planetary nebulae are nature's most breathtaking ephemeral art, typically lasting just tens of thousands of years, a blink in cosmic time. As aging stars shed their outer layers, the exposed cores heat the ejected gas, making it glow in vivid hues. But this one defies the rules. Its structure is pristine, its gases still energized, yet the engine that should power its brilliance is missing. The leading theory: its central star collapsed into a white dwarf so cold and faint it slipped beneath our detection threshold, leaving the nebula to glow like a lantern with no flame. Then there's the darker possibility. What if the star didn't fade quietly? Some models suggest it could have been hurled away by a close encounter with another object, perhaps a stealthy black hole or a runaway star, ripping the system apart so violently that the white dwarf was ejected into intergalactic space. Picture a ship cutting its anchor in a storm, the nebula left behind like a drifting lifeboat with no crew. Supporting this wild idea are strange velocity measurements showing the nebula's gases are perturbed, as if something massive tore through the system long ago. The nebula's isolation adds another layer of mystery. Most planetary nebulae reside in crowded galactic disks where stars are abundant. Finding one in the desolate halo is like discovering a single lit candle in a cavern. How did it get there? Chemical analysis offers a clue. Its gases are richer in heavy elements than typical halo material, suggesting its progenitor star was born in Andromeda's bustling disk before being flung outward by gravitational chaos. Now it floats alone, a glittering relic of turmoil that occurred billions of years ago. What makes this orphaned nebula truly invaluable is its defiance of time. Without the stabilizing radiation of its central star, the gases should have dispersed into the halo long ago, yet here it remains, its delicate structures intact. Some unseen force, perhaps magnetic fields woven through the gas or the gentle pressure of dark matter, seems to be preserving it against all odds. Every new observation peels back another layer, revealing that even in death, stars find ways to surprise us. This celestial afterimage challenges our assumptions about stellar life cycles. If white dwarfs can vanish so completely, how many others have we missed? And what other cosmic ghosts might be hiding in plain sight, their stories written in light we've yet to decipher? The universe rarely leaves loose ends, but here, in the depths of Andromeda's halo, one glowing question mark hangs in the dark, waiting for its answer. In the swirling depths of Andromeda's halo, a cosmic rebel defies the galaxy's very spin, a gargantuan ring of gas, hundreds of thousands of light years wide, rotating stubbornly backward like a wheel set against the current. This isn't just another gas cloud, it's a celestial paradox, a swirling testament to the violence of Andromeda's past. While most of the galaxy's gas moves in sync with its spiral arms, this ring churns in the opposite direction, a maverick with origins as dramatic as its behavior. The leading theory points to a brutal galactic collision, a smaller galaxy, perhaps a dwarf spiral, plunging into Andromeda at a steep angle billions of years ago. When their gas disks met, the intruder's momentum didn't align with Andromeda's spin, creating a whirlpool of counter-rotating material that refused to assimilate. Imagine pouring cream into coffee but stirring in the opposite direction. Some of the cream resists blending, forming temporary swirls of rebellion. Only in this case, the swirls have lasted for eons, a fossilized imprint of the moment Andromeda claimed another victim. What makes this ring so destabilizing isn't just its motion, it's the gravitational chaos it sows. As the backward-spinning gas interacts with Andromeda's native material, it creates shockwaves and turbulence like two weather fronts clashing in a storm. These collisions heat the gas, triggering pockets of erratic star formation where there shouldn't be any, and warping the orbits of nearby globular clusters. Some astronomers believe it's even altering the shape of Andromeda's outer halo, twisting the distribution of dark matter in ways we can't yet fully map. But the real enigma is its persistence. Galaxy mergers typically settle over time, with gas eventually aligning to the dominant rotation. Yet this ring remains defiantly offbeat, as if held in place by some unseen anchor. One provocative idea suggests dark matter might be the culprit, a subhalo of invisible matter left behind by the devoured galaxy could be gravitationally shepherding the gas, preventing it from dispersing. Alternatively, the ring might be continually fed by fresh gas siphoned from intergalactic space, a cosmic conveyor belt keeping the rebellion alive. For astronomers, this counter-rotating monster is more than a curiosity. It's a laboratory for studying how galaxies evolve through chaos. Every shockwave, every spark of unexpected star formation tells a story about the messy, unpredictable processes that shape the universe. Andromeda's backward spinning ring is proof that even the grandest structures in space don't always play by the rules. Sometimes they spin their own. Huddled in the depths of Andromeda's halo, a cluster of stars lingers like embers on the verge of fading stellar relics so ancient and cold they barely cling to visibility. These aren't just old stars, they're cosmic ice sculptures, their surfaces chilled to temperatures barely above the frigid void around them, emitting only the faintest infrared whispers. Most star clusters blaze with youthful energy or the steady glow of middle age, but this one exists in a state of near hibernation, its light so feeble it skirts the edge of detection. The mystery isn't just their age, it's their survival. Clusters this old should have disintegrated eons ago, their stars scattered by gravitational encounters or the relentless tug of Andromeda's tides. Yet here they remain, bound together with improbable resilience. One theory suggests they're shielded by an invisible scaffold of dark matter, a hidden gravitational net holding them in place. Picture a spiderweb so fine it's undetectable, yet strong enough to cradle the cluster against the galaxy's pull. Alternatively, their sheer isolation might be their salvation. Drifting far from Andromeda's bustling disk, they've avoided the gravitational turbulence that shreds most loose clusters, like a ship anchored in calm waters while storms rage elsewhere. Then there's their composition, a time capsule of the early universe. These stars are metal poor to an extreme, forged from primordial hydrogen and helium with almost no contamination from later supernova. Studying them is like analyzing air trapped in ancient amber, revealing the conditions of a time before planets or even complex elements existed. But their chemistry raises another puzzle. How did they form so densely without the heavier elements that typically help gas clouds collapse? One provocative idea is that they were born in a rare pocket of the early universe where dark matter's pull alone triggered star formation, bypassing the need for metal-rich seeds. The most haunting possibility, this cluster might not be unique. If such fragile structures can endure, the halos of galaxies could be littered with nearly invisible stellar fossils, ghosts of the universe's first chapters, hiding in plain sight. Every faint gleam from these frozen stars is a challenge to our understanding of time, gravity, and the silent endurance of the cosmos. Hidden in the depths of Andromeda's halo, a storm rages not of wind or rain, but of invisible forces twisting the fabric of space itself. This isn't just a magnetic field, it's a cosmic labyrinth where lines of force spiral and knot in ways that defy the orderly patterns seen elsewhere in the universe. Most galactic magnetic fields flow smoothly, like rivers of energy tracing the contours of spiral arms, but here they writhe like tangled wires warped by something we can't see. Some astronomers suspect the hands shaping this chaos belong to black holes, not the supermassive one at Andromeda's core, but smaller, hidden ones scattered through the halo, their gravity tugging at the magnetic fabric like invisible fingers. The evidence lies in cosmic rays, high-energy particles racing through space at nearly the speed of light. As these particles encounter the anomaly, their paths spiral wildly, their trajectories bent by the distorted magnetic landscape. It's like watching a river suddenly fork into a dozen erratic streams, each branch carving its own unpredictable course. The twist, these disruptions aren't random. They cluster in specific zones, forming patterns that suggest the presence of concentrated mass warping the field from behind the scenes. The leading theory points to intermediate mass black holes, the elusive middle children of cosmic giants lurking unseen in the halo. Their gravitational pull could be twisting the magnetic field like a spoon stirring honey, creating pockets of turbulence that redirect cosmic rays with eerie precision. But there's a darker contender, dark matter. If certain exotic particles interact weakly with magnetic fields, their collective gravity might sculpt the halo's magnetism into these bizarre shapes. Picture a shadow puppet show where unseen hands manipulate light. Only here, the hands are made of dark matter, and the light is the galaxy's own magnetic energy. The implications are staggering. If dark matter can twist magnetic fields on such vast scales, it would be the first clue that this mysterious substance does more than just exert gravity. It might actively shape the electromagnetic skeleton of galaxies. The real-world effects are just as profound. Cosmic rays funneled by this anomaly bombard nearby gas clouds, heating them and altering star formation. In some regions, the rays might even strip away the raw material for new stars, leaving behind cosmic deserts where stellar birth is stifled. Other areas, oddly enough, could benefit. The chaotic fields might compress gas in just the right way to trigger unexpected bursts of star formation, like a capricious weather system creating oases in a wasteland. What makes this magnetic maze so captivating isn't just its strangeness, it's the reminder that the universe's invisible forces are every bit as dynamic as the stars we see. Andromeda's twisted fields challenge us to rethink how energy, matter, and the unseen architecture of space intertwine, proving that even in the darkest corners of a galaxy's halo, there's no such thing as true emptiness, only mysteries waiting to be unraveled. Tucked away in the furthest reaches of Andromeda's halo, an entire galaxy hides in plain sight, not in the glare of starlight, but in the silent tug of gravity itself. This phantom satellite galaxy is so faint, so utterly devoid of luminous stars, that it betrays its presence only by bending the light of objects behind it, like a shadow passing over a starry backdrop. Most galaxies announce themselves with glittering arms or glowing cores, but this one is a ghost, its mass detectable solely by the way it warps spacetime around it. What makes this discovery so unsettling is how it upends our assumptions about galactic neighborhoods. Astronomers have long mapped Andromeda's satellite galaxies, small companions bound to the giant spiral by gravity, but they relied on starlight to find them. This invisible galaxy suggests we've been missing an entire population of cosmic phantoms, structures built not from stars but from something far more enigmatic: dark matter, rogue black holes, or even an entirely new class of failed galaxies that never ignited star formation. The very existence of such an object forces us to confront a humbling possibility. What if the universe is filled with galaxies we can't see, silently shaping the cosmos from the shadows? Then there's the puzzle of its origins. Did this galaxy form normally, only to have its stars stripped away by Andromeda's tides, leaving behind a skeletal halo of dark matter? Or was it born dark, a primordial structure that somehow avoided gathering enough gas to spark stellar birth? The answer could redefine how we understand galaxy formation. Most models assume dark matter halos act as scaffolds for luminous matter, but this phantom satellite suggests some halos might never attract the gas needed to light up. It's like finding an empty city built with roads, power lines, and buildings, but no people, no signs of life. The detection method itself is a marvel of modern astronomy. By studying subtle distortions in the light of distant quasars, tiny warps too slight for conventional telescopes, researchers pieced together the galaxy's mass and rough outline. These gravitational fingerprints hint at a structure spanning thousands of light years, yet emitting less visible light than a single modest star cluster. Some theories propose it's not alone. Similar invisible galaxies might lurk throughout Andromeda's halo, their combined gravity subtly influencing the motions of visible stars in ways we've only begun to notice. But the most tantalizing question isn't just how many of these phantoms exist, it's what they imply about the nature of dark matter. If this galaxy is held together by dark matter alone, its structure could reveal whether those elusive particles interact in ways beyond gravity, clumping or dispersing under rules we've yet to decipher. Every unseen galaxy we discover is another piece in the puzzle, another whisper from the universe's hidden majority. And as our tools grow sharper, one thing becomes clear: the cosmos is far stranger and far darker than we ever imagined. Deep in the swirling outskirts of Andromeda's halo, a celestial graveyard holds the remains of countless dead stars, not scattered loosely, but packed together in a bizarrely dense congregation that defies explanation. This is no ordinary field of stellar remnants. It's a cosmic ossuary where white dwarfs and neutron stars cluster with unnatural tightness, their combined gravity creating subtle ripples in the fabric of space itself. Most stellar corpses drift apart over time, but here they linger in eerie proximity, as if drawn together by some unseen force. The density alone is enough to puzzle astronomers. White dwarfs, the smoldering cores of dead sun-like stars, typically float hundreds of light years apart, their distribution reflecting the gentle drift of galactic tides. But in this patch of the halo, they're crammed nearly shoulder to shoulder, with neutron stars, the ultra-dense remnants of supernova, lurking among them like silent sentinels. The leading theory points to a cataclysmic origin. This could be the fossilized core of a globular cluster, a once vibrant community of stars that aged together before their deaths left behind this compact necropolis. Picture a bustling city reduced to crumbling tombstones, all huddled on a single hill. But there's another, darker possibility. The arrangement might not be natural at all. Some researchers suggest these dead stars were herded together by the gravitational pull of something invisible, perhaps an intermediate mass black hole hidden at the cluster's heart. Black holes this size are notoriously elusive, but their gravity could explain why these stellar remnants refuse to disperse, orbiting an empty point like moths circling a vanished flame. Alternatively, the graveyard might trace the path of a dwarf galaxy Andromeda devoured long ago, its stars stripped away while their dead cores remained, clumped like beads on a broken necklace. What makes this graveyard truly unsettling is its silence. White dwarfs cool over billions of years, fading into darkness, while neutron stars, unless their pulsars, emit no light at all. To casual observers, this region would appear nearly empty, a void within a void. Yet the gravity of these invisible remnants shapes their surroundings in subtle ways, warping the orbits of passing stars and bending light from distant galaxies. It's a place where the past lingers, not in glittering starlight, but in the quiet, persistent tug of mass without radiance. The implications stretch far beyond Andromeda. If such graveyards are common, they could rewrite our understanding of how stellar populations evolve. Galaxies might be riddled with these shadowy clusters, their combined mass altering the gravitational landscape in ways we've only begun to map. Every dead star here is a witness to epochs long vanished, and their strange congregation hints at forces we're only beginning to comprehend, a reminder that even in death, stars have stories to tell. Floating in the emptiness between galaxies, a ring of glowing debris expands silently, the shattered remains of a star that died far from home. This isn't just another supernova remnant, it's a cosmic castaway, drifting in the void where no star should have exploded. Most supernovae light up the crowded streets of galaxies, their ejecta colliding with nearby gas to create radiant shockwaves. But this one detonated in the desolation of intergalactic space, its shockwaves rippling through near nothingness, a solitary firework exploding in an endless night. How does a star end up so far from any galaxy? The answer lies in gravitational betrayal. Billions of years ago, this star likely belonged to a small galaxy that ventured too close to Andromeda's crushing tides. As the dwarf galaxy was torn apart, some of its stars were flung into the abyss like sparks from a spinning grindstone fast enough to escape entirely. This star, now a ghostly remnant, was one such exile, wandering the darkness until its core collapsed and it erupted in a final, solitary act of defiance. What makes this remnant so fascinating isn't just its isolation, it's the purity of its debris. In galaxies, supernova ejecta mix with interstellar gas, complicating the chemistry we observe. But here, the explosion's aftermath remains pristine, uncontaminated by surrounding material. Spectroscopic studies reveal the elemental fingerprints of a star that lived and died in near-total isolation. Lighter elements like oxygen and neon dominate, with far less of the heavier metals typically forged in crowded stellar environments. It's like finding an untouched archaeological site where every artifact tells a clearer story because no later civilizations disturbed it. Then there's the shape. Without interstellar gas to slow it down, the remnant shockwave has expanded into a near-perfect sphere, a rarity among supernovae. Most remnants are twisted by uneven gas densities, their structures warped like bubbles blown into turbulent water. This one, though, is strikingly symmetrical, its edges sharp and well-defined, a frozen moment of a shockwave traveling through nothingness, unimpeded. But the true surprise came when astronomers studied its motion. The remnant isn't drifting aimlessly, it's racing back toward Andromeda, pulled by the galaxy's gravity like a boomerang returning to its thrower. That trajectory suggests something extraordinary. The star might have been part of a hypercompact cluster, a tight knot of stars ejected together during the galactic collision. If so, its siblings could still be out there, hiding in the halo's darkness, their own fates yet to unfold. This lonely remnant is more than a curiosity. It's a time capsule from an event we rarely witness, the death of a star untethered from the galaxy that birthed it. Every ripple in its expanding shell, every atom in its debris, tells a story of exile, isolation, and the unpredictable violence of the cosmos. And as it glows faintly against the void, it reminds us that even in the emptiest corners of the universe, the stars find ways to make their mark. Deep in the halo of the Andromeda Galaxy, a globular cluster glows with an unsettling secret. Its gravity is far stronger than its stars alone can explain. This isn't just another ancient ball of stars, It's an enigma wrapped in darkness, where the visible matter accounts for barely a fraction of the mass required to hold the cluster together. Something invisible and massive lurks among these stars, bending their orbits like an unseen hand guiding marionettes. The puzzle begins with the cluster's motion. Normally, astronomers calculate a globular cluster's mass by measuring how fast its stars orbit. The center. Faster orbits imply more gravity and thus more mass. But in this case, the numbers don't add up. The stars whiz around so quickly that, based on their luminosity alone, the cluster should have torn itself apart long ago. Instead, it remains eerily intact, as if bound by ghostly chains. The leading suspect, dark matter. Unlike typical globular clusters, which are thought to be relatively clean of this mysterious substance, this one might be drowning in it, its stars swimming through an invisible sea of mass that outweighs them by orders of magnitude. Yet dark matter isn't the only contender. Some researchers argue the cluster could harbor something even more exotic, a hidden nest of black holes. Imagine dozens, perhaps hundreds of stellar mass black holes, remnants of massive stars that collapsed long ago, now lurking unseen in the cluster's core. Their combined gravity could explain the missing mass, warping the orbits of nearby stars without emitting a single photon of light. Simulations support this idea, showing that black holes tend to sink toward the center of clusters over time, forming an invisible gravitational anchor. But here's the twist: if black holes dominate, why hasn't their relentless tug sent stars flying out of the cluster entirely? The delicate balance of this system suggests a fine-tuned arrangement, almost too precise to be natural. Then there's the wild card theory. What if this isn't a globular cluster at all? Its chemical makeup hints at a stranger origin. Most globular clusters are metal-poor relics of the early universe, but this one's stars contain trace elements that suggest a more complex history. Some astronomers propose it's the stripped core of a dwarf galaxy, its outer stars ripped away by Andromeda's tides, leaving behind a dense kernel of stars, and whatever dark matter or black holes once held it together. If true, it would blur the line between globular clusters and galaxies, forcing us to rethink how such structures form and evolve. The implications ripple far beyond Andromeda. If dark matter can invade globular clusters, it challenges decades of assumptions about where this elusive substance congregates. If black holes are the culprit, it means these clusters could be far more dynamic and far darker than we ever imagined. Every observation peels back another layer, revealing a cosmic masquerade where nothing is quite what it seems. One thing's certain: in the silent depths of this enigmatic cluster, the universe is hiding something extraordinary, and we're only beginning to grasp what it might be. Drifting unnoticed through the frigid expanse of Andromeda's halo, an entire population of orphaned worlds wanders in perpetual night. Not stars, not asteroids, but rogue planets, cast adrift from their birthplaces to roam the darkness alone. These frozen nomads form a vast, invisible archipelago, a cloud of worlds untethered from any sun, each one a silent testament to the chaos of galactic evolution. Unlike the orderly planets of our solar system, orbiting obediently around their star, these exiles travel solitary paths, warmed by nothing but the faint decay of radioactive elements in their cores and the occasional gravitational squeeze as they pass near other outcasts. What makes this rogue planet cloud so extraordinary is its sheer scale. Current estimates suggest Andromeda's halo could harbor billions of these free-floating worlds, outnumbering the stars in its disk by a staggering margin. They range from gas giants larger than Jupiter to rocky bodies roughly Earth-size, all ejected from their original systems by gravitational turmoil, perhaps a close encounter with a passing star, or the violent reshuffling that occurs when galaxies collide. Picture a cosmic game of pinball where planets are the balls and gravity the flippers, sending them careening into the abyss. Some may have even been torn from their orbits during Andromeda's ancient feasts, when it devoured smaller galaxies and scattered their celestial children like seeds in the wind. The conditions on these worlds are beyond extreme. Without a sun, their surfaces, if they have solid surfaces at all, are frozen wastelands where temperatures hover just above absolute zero. Any atmospheres they once possessed have likely collapsed into icy shells or been stripped away by the relentless radiation of interstellar space. Yet there's a haunting possibility. Deep beneath the ice of some, tidal heating or residual geothermal energy might sustain hidden oceans similar to Jupiter's moon Europa. If so, these darkest of worlds could, against all odds, harbor environments where life clings to existence, utterly isolated from the light of any star. Tracking these invisible exiles is a feat of astronomical ingenuity. Without sunlight to illuminate them, rogue planets are detected indirectly through microlensing, the subtle way their gravity bends and magnifies the light of distant stars as they pass in front of them. Each tiny flicker in a star's brightness is a breadcrumb, leading scientists to another hidden world. Recent surveys suggest these planets might even carry their own moons, snatched along during their violent ejection, creating binary systems of frozen companions drifting together through eternity. The implications rewrite our understanding of planetary formation. If rogue planets are this abundant, it means planetary systems are far more chaotic and fragile than we imagined. For every neat, orderly solar system like our own, there could be dozens of disrupted ones, their planets lost to the void. Some researchers even speculate that rogue planets might be the universe's dark horses ferrying the ingredients for life between stars, or acting as stepping stones for future interstellar travelers. But perhaps the most poignant thought is their impermanence. Over trillions of years, most will slowly evaporate, their heat bleeding into space until they become little more than cold, inert husks. Others might be recaptured by passing stars, given a second chance at planetary life. A rare few could even collide, their impacts lighting up the halo with fleeting sparks in the darkness. Yet for now they drift, an unseen archipelago of lost worlds, each one a monument to the tempestuous nature of cosmic existence. Hidden in the faint glow of Andromeda's halo lies a whisper from an era when the galaxy was young and violent, an ethereal arc of ultraviolet light stretching like a phantom scar across the darkness. This isn't just scattered starlight, it's the fading echo of a quasar that once blazed with the fury of 1,000 galaxies, a relic from a time when Andromeda's core was a raging inferno. Billions of years ago, as gas and stars spiraled into the supermassive black hole at the galaxy's heart, the resulting quasar outshone Andromeda itself, pumping out enough energy to ionize gas hundreds of thousands of light years away. Today, all that remains is this fragile afterglow, a cosmic fossil illuminating the halo in ways no modern telescope could replicate. What makes this echo so invaluable is its ability to map history. As the quasar's radiation blasted outward, it excited atoms in the halo's sparse gas, causing them to absorb and re-emit specific wavelengths of light. The patterns in that re-emission act like a time-stamped ledger, recording the density, temperature, and composition of the halo's gas at the exact moment the quasar's light passed through it. It's as if the universe dipped a quill in invisible ink, writing secrets across the sky that only now, with the right instruments, we've learned to read. The most startling revelation, the halo's gas isn't uniform. The echo reveals vast, billowing structures, clouds of ionized hydrogen sculpted by ancient supernova shocks or gravitational tides from long-vanished satellite galaxies. Some regions are nearly empty, their gas stripped away by eons of galactic winds, while others cling to traces of heavy elements, the chemical residue of stars that lived and died before Earth formed. These variations tell a story of chaos and change, proving Andromeda's halo has never been the static envelope we once imagined, but a dynamic, ever-evolving frontier. Yet the real puzzle is the echo's longevity. Quasar afterglows typically fade within millions of years as the gas recombines and settles back into darkness. For this one to persist, albeit faintly, suggests something is keeping the halo's gas agitated. Could Andromeda's central black hole still be flickering, its occasional outbursts reheating the halo like a dying campfire's last embers? Or is the gas being stirred by collisions with unseen dark matter subhalos, their gravity rippling through the halo like stones tossed into a pond? For astronomers, this ghostly arc is more than a curiosity, it's a time machine. By comparing its light to younger quasar echoes in distant galaxies, they can trace how galactic halos evolve over cosmic epochs, watching as they grow richer in metals and more complex in structure. It's a rare chance to witness Andromeda's adolescence, frozen in ultraviolet ink, waiting to be decoded. Every photon carries a message from an era when the universe was fiercer, brighter, and far more unpredictable, a reminder that even the quietest corners of space were once alight with violence. The warped star stream twists through Andromeda's halo like a cosmic ribbon caught in an invisible current, a river of stars so grotesquely bent that it shouldn't exist under normal galactic physics. Unlike the smooth, elegant arc of the giant stellar stream we explored earlier, this structure is mangled, its once coherent path now kinked and contorted as if some unseen hand grabbed it mid-flight and wrung it like a washcloth. These aren't just random distortions, they're gravitational fingerprints, evidence of violent encounters with invisible clumps of dark matter lurking in the halo's depths. Here's why this matters. Star streams are supposed to be fragile. When a dwarf galaxy gets torn apart by a larger galaxy's tides, its stars stretch into long, thin filaments that under normal circumstances should remain smooth as they orbit. But dark matter doesn't play by those rules. As the stream snakes through the halo, it brushes against dense pockets of this mysterious substance, each one yanking at the stars like a magnet tugging iron filings. The resulting bends and kinks act as a cosmic seismograph, recording every dark matter interaction in exquisite detail. By mapping these twists, astronomers can reconstruct the hidden architecture of Andromeda's halo in ways no telescope could achieve directly. The most jaw-dropping revelation, the sheer number of distortions, suggests Andromeda's halo is littered with far more dark matter substructures than simulations predicted. According to leading models, dark matter should be distributed relatively smoothly, with only a few large clumps. But the warped star stream tells a different story. Its undulations point to dozens, perhaps hundreds, of invisible mass concentrations. Some could be the remnants of devoured dwarf galaxies, their stars long since assimilated but their dark matter halos stubbornly holding on. Others might be primordial knots, relics from the universe's first moments that never fully dissolved into the halo's diffuse background. But the stream isn't just a passive witness to these encounters. The very stars within it are changing. As dark matter tugs them off their original orbits, they spread out, their velocities scattering like leaves in a gust. Over time, this heating effect could dissolve the stream entirely, erasing it from the cosmos. That makes it a fleeting artifact, a cosmic detective with an expiration date. Every observation is a race against time, a chance to decode the stream's wrinkles before they fade into the halo's anonymity. What's truly groundbreaking is how this phenomenon flips traditional astronomy on its head. Normally, we study the universe by observing light, but here, the absence of light, the unseen hand of dark matter, is what shapes the narrative. The warped star stream isn't just an oddity, it's a blueprint, a Rosetta Stone for deciphering the language of the invisible universe. And with every new kink we uncover, we're one step closer to answering the ultimate question. What exactly is the dark matter that binds our cosmos together? Tucked into the quiet fringes of Andromeda's halo, a time capsule floats in perfect isolation. A cloud of hydrogen so pristine, it's as if the universe forgot it existed. This isn't just another wisp of gas, it's a relic from an era before stars, before galaxies, before the cosmic forge had even begun smelting heavier elements. Unlike the chemical-rich clouds we see elsewhere, This pocket is a fossilized breath of the early cosmos, composed almost entirely of hydrogen and helium, with no trace of the metals that define modern interstellar material. Its purity is so extreme, it's like finding an untouched glacier from Earth's ice age, its layers uncontaminated by millennia of human industry. What makes this gas pocket so extraordinary isn't just its age, it's the miracle of its survival. For over 13 billion years, it's avoided the gravitational pull of stars, the shock waves of supernova, and the violent turbulence of galactic collisions. Most primordial gas was swallowed long ago by growing galaxies, recycled through generations of stars and spat out as metal-enriched debris. Yet this cloud lingers, a silent witness to a time when the universe was a simpler, emptier place. How did it endure? One theory suggests it's been cocooned in a quiet eddy of the halo, a cosmic backwater where the chaos of star formation never reached. Another proposes it's shielded by dark matter, an invisible umbrella deflecting the gravitational tides that might have torn it apart. The real enigma lies in its chill. This gas isn't just pristine, it's colder than the space around it, hovering just a few degrees above absolute zero. Normally, gas clouds this cold should collapse under their own gravity, igniting new stars. But here, the particles seem suspended in stasis, as if time itself has slowed. Some researchers speculate that without even trace amounts of metals or dust to catalyze cooling, the hydrogen lacks the means to shed energy efficiently, leaving it stuck in a state of near-perpetual equilibrium. It's a cosmic catch-22. The very purity that preserves the cloud also prevents it from transforming into something new. Yet the most tantalizing question isn't how it survived, it's how many others like it might be hiding in plain sight. If this pocket exists, others could lurk in the halos of galaxies across the universe, each one a snapshot of the cosmos in its infancy. Discovering them would be like uncovering a lost library of the universe's first moments, written in the language of unspoiled atoms. For now, this lone cloud remains a paradox, a whisper from the dawn of time, too fragile to last, yet too stubborn to fade away. Deep in Andromeda's halo, a cosmic dance of destruction unfolds, two black holes locked in a gravitational embrace so tight their fate is already sealed. This isn't just any pair, it's a binary system of monsters, one weighing in at nearly 50 times the mass of our Sun, the other even larger, both spiraling toward a collision that will shake the fabric of spacetime itself. They're relics of a smaller galaxy Andromeda devoured long ago, its stars assimilated, its gas absorbed, leaving only these dark hearts behind, still circling each other like ghosts of a forgotten battle. What makes this duo so mesmerizing is the inevitability of their end. Right now, they're separated by a distance roughly equal to our solar system's outer planets, close enough to warp each other's orbits, yet still too far to merge. But gravity is patient. With each loop around their shared center of mass, they lose energy in the form of gravitational waves, those faint ripples in spacetime predicted by Einstein. Over millions of years, those waves will act like cosmic brakes, slowing their motion, tightening their spiral until there's no escape. When they finally collide, the explosion will outshine every star in Andromeda combined, releasing more energy in a fraction of a second than our Sun will emit in its entire lifetime. The clues to their origins lie in their motion. Unlike solitary black holes that wander the halo like silent predators, this pair moves with a peculiar rhythm, their paths tracing a delicate helix through space. That signature spin suggests they were once the central anchors of two separate galaxies that merged, leaving their black holes to settle into this deadly orbit. Normally, when galaxies collide, their central black holes should find each other quickly, drawn together by friction from gas and stars. But these two took longer than expected, hinting at a violent past where they were flung into the halo's outskirts before finally being captured by each other's gravity. The final act will be a spectacle beyond imagination. As they near merger, their event horizons will stretch and distort, spiraling faster until they're whirling thousands of times per second. The resulting gravitational waves will reverberate across the universe, carrying the signature of their masses, spins, and final moments. When the ripple reaches Earth, likely billions of years from now, it will stretch and compress our planet by less than the width of an atom, a whisper so faint only our most sensitive detectors could catch it. But the aftermath will be even stranger. The newborn black hole will recoil from the explosion, potentially rocketing through the halo at hundreds of kilometers per second, a runaway bullet forged from the fusion of two nightmares. Yet the most profound implication isn't the collision itself. It's what this system tells us about the hidden architecture of galaxies. If binary black holes exist in Andromeda's halo, they're likely common throughout the cosmos, remnants of the chaotic mergers that built the universe's largest structures. Every spiral galaxy's serene beauty might hide dozens of these dark duos, each one a ticking clock counting down to a cataclysm we're only beginning to understand. And as we watch these two monsters circle, we're glimpsing a future that awaits all galaxies, even our own. At the edge of Andromeda's halo, the universe plays a trick on our eyes, a distant galaxy stretched and twisted into a shimmering arc, as if viewed through a cosmic funhouse mirror. This isn't a defect in our telescopes, it's one of nature's most elegant illusions, a gravitational mirage where light itself bends around Andromeda's immense mass. The phenomenon, called strong gravitational lensing, transforms a background galaxy billions of light years away into a surreal, fragmented halo of light, warped into rings, arcs, or even multiple ghostly copies of itself. What makes this mirage so invaluable isn't just its beauty, it's the way it acts as a cosmic scale, revealing the invisible scaffolding of Andromeda's halo. The amount of distortion depends on the mass between us and the background galaxy, meaning every curve in that stretched starlight is a clue to the distribution of dark matter. Think of it like holding a magnifying glass over a newspaper, except here, the glass is made of gravity and the distorted text is a map of unseen forces. By measuring how severely the background galaxy's light is bent, astronomers can reconstruct the halo's hidden mass with precision no telescope could achieve directly. The real magic lies in the details. Unlike a single, smooth lens, Andromeda's halo is lumpy, its dark matter clumped into subhalos left behind by devoured dwarf galaxies. These irregularities leave fingerprints on the mirage, creating subtle kinks or extra warps in the lensed image. It's as if we're decoding shadows cast by invisible structures, each anomaly a whisper from a long-dead satellite galaxy. Some distortions even hint at black holes drifting through the halo, their gravity carving tiny dimples in the lensed light like stones dropped into a pond. But the mirage isn't just a passive snapshot, it's a time machine. The background galaxy's light has traveled far longer to reach us than Andromeda's, meaning we're seeing it as it existed when the universe was younger. The lensing effect preserves that ancient light, magnifying it like a natural telescope. In some cases, these mirages allow us to study galaxies so distant they'd otherwise be invisible, their faint glow amplified by Andromeda's gravitational grip. It's a cosmic two-for-one, a map of dark matter in our backyard and a window into the early universe beyond. Yet the illusion holds one final puzzle. Sometimes the mirage flickers, variations in the background galaxy's brightness, supernova, quasars flaring, can appear at slightly different times in each warped copy due to the varied paths their light takes around Andromeda. By tracking these delays, astronomers can measure the expansion rate of the universe itself, testing whether our cosmic rulers align with predictions. This shimmering deception is more than just a curiosity, it's proof that even empty space isn't truly empty. The universe writes its secrets in bent light, and Andromeda's halo, with its ghostly lensed arcs, offers one of the clearest dictionaries we've ever found. Every distorted galaxy is a lesson in gravity's reach, a reminder that the cosmos speaks in riddles, and sometimes the most profound truths come dressed as illusions. At the farthest reaches of Andromeda's halo, where the glow of the galaxy fades into the void, a single ancient star stands sentinel, a cosmic relic so old its light may have been among the first to pierce the darkness when Andromeda itself was young. Unlike the bustling stellar neighborhoods closer to the galactic core, this solitary giant burns in near-total isolation, a survivor from an era when the universe was still carving out its first structures. Its chemical makeup reads like a cosmic birth certificate, almost no traces of heavy elements, just the pristine hydrogen and helium that filled the early cosmos before generations of supernova could seed space with metals. What makes this star truly extraordinary isn't just its age, it's the story written in its atmosphere. Spectroscopy reveals a composition untouched by the pollution of later stellar generations, a rare window into the raw ingredients of galaxy formation. Most stars in Andromeda's disk are metal-rich, forged from gas recycled through countless cycles of star birth and death, but this outlier is different. Its purity suggests it formed from a collapsing cloud of primordial gas, a rare pocket that somehow avoided contamination during the galaxy's violent adolescence. It's like finding a single, unbroken vase amid the fragments of a shattered pottery workshop, a fleeting glimpse of what existed before the chaos of cosmic construction began. The star's position is equally telling. Floating at the halo's edge, it defies the usual distribution of such ancient objects, which typically cluster near the galactic center. One theory suggests it was flung outward during Andromeda's early growing pains, hurled into the outskirts by gravitational slingshots as smaller protogalaxies merged to form the spiral we see today. Alternatively, it might have formed in situ, a lone spark igniting in the halo's sparse gas before star formation recipes included the heavier elements needed to build planets or life. Yet the most tantalizing clue lies in its motion. Unlike younger stars that orbit Andromeda in orderly planes, this elder follows a wild, looping path that cuts steeply through the halo. That erratic trajectory mirrors predictions for stars stolen from dwarf galaxies during collisions, raising the possibility that this isn't one of Andromeda's original children at all, but a refugee adopted during the galaxy's rapacious youth. Either way, its very existence challenges our timelines for how galactic halos assembled their oldest stellar populations. This star isn't just a curiosity, it's a time capsule from an epoch when the universe was still experimenting with how to build galaxies. Every flicker of its faint light carries data about the conditions that birthed Andromeda, offering clues to questions we're only beginning to ask. How did the first stars influence their galaxies? What forces shaped the halos we see today, and how many other primordial sentinels linger in the darkness, waiting to share their stories? In the silent expanse of the halo, this ancient beacon reminds us that sometimes the most profound history lessons come from the unlikeliest of teachers, a single star burning quietly at the edge of everything. From the ghostly giant stellar stream to the rogue planets drifting in eternal night, Andromeda's halo is a gallery of cosmic oddities, each one a puzzle piece reshaping how we see galaxies. These 30 enigmas aren't just curiosities, they're revolutionaries. The hypervelocity stars racing toward oblivion, the invisible dark matter clumps bending space-time, the phantom galaxies made of shadows. They all whisper the same truth. Galaxies aren't static islands of stars, but dynamic, ever-changing beasts shaped by collisions, cannibalism, and forces we're only beginning to understand. Consider the implications. That rogue supermassive black hole hurtling through the halo proves even the universe's most powerful objects can be catapulted into exile. The ultra-diffuse galaxy, clinging to existence despite its near weightlessness, defies our models of galactic survival. And the gamma-ray fog, could it really be dark matter decaying before our eyes, or just another cosmic sleight of hand? Every discovery here forces us to rewrite the textbooks, revealing that halos aren't mere afterthoughts, but archives of a galaxy's violent past and blueprints for its future. But here's the most exhilarating part: we've barely scratched the surface. If Andromeda's halo holds this many surprises, imagine what lurks in the halos of galaxies a billion light-years away, or even our own Milky Way, whose secrets may be just as strange. The universe thrives on defying expectations, and every oddity we uncover is an invitation to look deeper, question harder, and embrace the beautiful chaos of the cosmos. So what's your take? Which of these halo mysteries fascinates you the most? Could the dark matter anomalies hint at new physics? Might the orphan stars lead us to undiscovered dwarf galaxies? Drop your theories below, because the greatest discoveries often start with a simple question, and who knows, your idea might just be the key to unlocking the next cosmic enigma. Until then, keep gazing upward. The universe has far more wonders in store.